Hello everyone, my name is Sen Chen from Nanyang Technological University. Welcome to my presentation, an empirical assessment of security risks of global Android banking apps. As we all know that financial service apps such as banking apps are widely used in our daily life and have changed our lives. People use this app to conduct financial services such as transfer funds and pay bills. However, some security vulnerabilities inside this app will cause severe threat to mobile users, and attackers can exploit these vulnerabilities to steal user money and users' sensitive data. According to a recent report, 70% of top 100 mobile banking apps are vulnerable security attacks and data leakage. Let's see a real example. A banking app named GCash with 10 million downloads on Google Play. And when you register the app, you need to type PIN code, first name, last name, and address. And all of this sensitive data will be sent by SMS and will also log the output. Attackers can explore these two vulnerabilities to steal users' sensitive data. So motivated by the above observation, we aim to conduct such study to investigate the overall security states of global Android banking apps and other research directions. And consequently, we can provide fixing recommendation and useful findings. But first, we need to investigate the existing static security assessment tools and collect the corresponding dataset. And after conducting an in-depth comparison study, we found that existing static assessment tools most focus on their pattern-based checking, and will output a lot of false positives. And the last but not least, they cannot be used to detect most of the data leakage-related vulnerabilities. So we need to develop our own tool. Before that, we propose and integrate a taxonomy of data-related security weaknesses, which contains 4 main categories and 22 security weaknesses. By leveraging static program analysis, giving a banking app as input, we use a forward data flow analysis to identify what the sensitive data is, how to trigger the leakage and where the data is leaked. And we also use a backward control flow analysis to reduce false positives. We also combine the pattern-based approach to examine the authentication and the encryption security weaknesses. And due to time limitation, if you are interested in the technical implementation, please refer to our exit paper. As for the evaluation part, we select 60 banking apps as our comparison subjects. As shown in this table, we can see that all 0 achieved the best performance, not only the number of security weaknesses, but also the precision. Okay, today I will take more time on the results. We make substantial effort to collect 693 global banking apps from over 80 countries, and we got over 2,000 security weaknesses. Among them, there are 592 cases of sensitive data leakage, and even worse, there are 82 cases of credentials leakage, such as PIN code and password. When it comes to the communication security, we found that 222 apps are using invalid authentication, which cause severe man-in-the-middle attack. And according to the different colors, we can see that Asia and South America hold the severe security status, and Africa achieves a better security status because some financial services date from Africa. And besides the statistic of security weaknesses, we also conduct a multiple version analysis. Note that some banks developed different versions for different countries. So we examined all of the country versions for the top 5 banks. And we conclude that app security weaknesses vary across different markets by countries and bring fragmentation problems among different versions of the same banking apps. And the apps owned by the subsidiary banks are less secure than or equivalent to their banks owned by their parent banks. And the observation is evidenced by the South Korean version of Citibank app and the Chinese version of HSBC app. And actually, the vulnerability reporting process is inefficient and which causes several months and hundreds of emails. How about the patching process? Until now, 21 banks have confirmed our reported vulnerabilities in different ways, active response and silently patched. And 10 banks have confirmed our reported vulnerabilities by emailing us positive feedback. And 7 of them have patched our reported vulnerabilities. And the remaining 3 banks claimed that they will fix our reported vulnerability in the next release version. And another 11 banks also patched our reported vulnerabilities, but we don't have received any response from them, but they indeed patched our reported vulnerability. And until now, 52 reported vulnerabilities have been patched. So the patch rate is 41.27%. And when they fixed our reported vulnerabilities, 5 new vulnerabilities introduced in the release new versions, which indicates that the security assessment process is immature in the industrial banks. Here we highlight the feedback. We received 114 emails, and we also conduct 7 in-person or online meetings with the industrial banks and discuss the report details. And we also highlight that we received acknowledgement letters from industrial vendors such as HSBC in UK and OCBC in Singapore. And in the future, we will focus on the security risk assessment of Android apps, and we will take all the components into account, such as source code, third-party libraries, and native code. Besides the security vulnerability report, we will also provide security risk score to users, developers, and other customers. Okay, that's all. Thank you for your attention.